Hey there. Pretty much anyone can write code that, well, runs. But writing professional code, code that's secure, that's easy to manage, and that's actually built to last, that takes a whole different set of tools. Today, we're going to dive into the absolute essential building blocks in Java that really separate the amateur stuff from professional-grade software. So, let's start with a question. When you create an object in your code, is the data you put inside it actually safe? Or can any other random part of your program just reach in and start messing with it? This right here is the first big problem we're going to solve. How do you stop that uncontrolled, chaotic access to your data?
I want you to think of the data inside your classes like it's treasure in a vault. You wouldn't just leave the vault door wide open for anyone to walk in, would you? Of course not. You'd post guards. Well, in Java, our first line of defense is a pair of really powerful gatekeepers.
And wow, the difference is like night and day. On the left, without these gatekeepers, your data is a total free-for-all. It's insecure, you can't check if the new data is even valid, and it completely shatters a core programming principle called encapsulation. But on the right, access is controlled. It's safe. You get to make the rules for how data can be changed, which is the mark of a pro.
So who are these gatekeepers? We call them getters and setters. A getter's job is super simple. It just lets other parts of the code read a value. A setter's job is to let them update that value, but, and this is the key part, it's on your terms. They act like a secure checkpoint for every single interaction with your data.
If you remember just one thing from this section, please let it be this. This isn't just a friendly suggestion, it's the golden rule of good object-oriented programming. Lock your data down by making it private, and then provide controlled public access through these special methods. And here's exactly how it works in the real world. That private string name, that's our treasure. It's locked away so nobody can touch it directly. The public getName and setName methods, those are our trusted gatekeepers. They are the only way the outside world is allowed to interact with that name variable. Okay, so we've secured our data. That's a huge first step. But what about the moment an object is first created? How do we guarantee 100% that it starts off in a valid, predictable state every single time? Let's move on to our next essential tool. Without a proper setup plan, you're stuck initializing your object one piece at a time manually. It's tedious, and worse, it's so easy to forget a step and create a broken object. But with a constructor, that setup is completely automatic. It's like having a foreman on an assembly line who makes sure every single item is built perfectly to spec right from the start. So what in the world is a constructor? Well, it's a very special method that has one job and one job only: to get a new object ready for action. The trick to spotting one is that it always has the exact same name as the class. And here's the really important part. It has no return type, not even void. It just runs automatically one time the second an object is born. And check this out in action. The moment your code says new student, boom, the student constructor instantly kicks in and does its thing. This is our golden opportunity to set default values and make absolutely sure our new object starts its life in a good, valid state. A lot of people get constructors and methods mixed up, so let's just clear the air right now. A constructor's purpose is purely initialization. A method's purpose is to perform some kind of action. A constructor must have the same name as the class. A method can be named whatever you want. And the big one, constructors have no return type and are called automatically, while methods must have a return type and have to be called manually. So we've already talked a little about private and public, but there's a whole system behind this. The best way to think about them is like security badges. They determine who in your code gets to open which doors. These security badges are officially called access modifiers. They're just keywords you put in front of a class or a variable or a method, and they set the rules. They define the visibility level and are basically the rules of engagement for your entire application. Java gives us 4 of these levels. Public is like the main entrance to the building. Anyone can get in from anywhere. Private is the total opposite. It's the most restricted, like the delicate inner mechanics of the vault, only accessible from right there inside the same class. And then you've got protected and defaults in the middle, which give access to other related classes. All right, let's tackle our final big idea. What if you have a piece of information that doesn't really belong to just one object, but should be shared by all objects of a certain type? Like, say, the name of a university for every single student object. How do we handle that without wasting a ton of memory? Well, the answer is a simple but powerful keyword: static. When you declare something as static, you're basically saying, hey, this doesn't belong to any one object. This belongs to the class as a whole.
It becomes a single common resource that all instances of that class can share. Look, this diagram makes it crystal clear. We have two separate student objects here, Object 1 and Object 2. See how they each get their own copy of stu name and stu ID? But they both share the exact same static school name and school regno. That means there's only one copy of that school data stored at the class level. It's way, way more memory efficient.
So let's really lock this in. Non-static stuff belongs to an individual object. Static stuff belongs to the class. This means every new object gets its own copy of non-static variables, but there's only one single copy of the static ones for everyone to share. And you access them differently. You use an object to get to non-static things, but you can use the class name itself to get to static things.
And there you have it, getters and setters to control your data, constructors to guarantee a perfect start every time, access modifiers to define crystal clear boundaries, and the static keyword to share resources in a smart, efficient way. These aren't just four random features. They are the interlocking pieces of the puzzle that let you build robust, secure, and truly professional code.
Look, getting a handle on these four concepts, it is a massive leap forward. It's the difference between just hacking something together that works and actually engineering software that's reliable and maintainable. These really are the foundational building blocks of a professional developer.
So you have the tools now. You've got the fundamental techniques to build higher quality, more secure, more professional applications. The only question left is, what are you going to build?